Hello students, this is Mahfuzur Rahman, Assistant Professor, Department of Computer Science and Application, C. Abdul Hakim College, Autonomous, Melvisharam. Database Management System. So we are under the subject Database Management System. We are going to discuss the topic on Relational Algebra. So here Relational Algebra helps in querying the statements based on the operators. So there are various operators comes under the relational algebra, which helps in retrieving the data from the tables, that is relation. So let's see what are the various operators under the relational algebra. Those are all select, project, union, intersection, difference, Cartesian product, rename. Those are all the various relational algebra operators which helps us in retrieving the data according to the conditions which is applicable for the data to be retrieved from the relation. Here first comes select operation. What the select operation does is, select operation entirely selects the contents from the table based on the tuples. So here there is an notation for that, that is select symbol P of R. Here what select symbol is defined is, it is denoted as sigma, and sigma is used for selection prediction, R is used for relation, P is used as propositional logic. So there are various logics under this propositional logic formula. So let's have an example here. See the table which is named as loan. This table contains branch name, loan number, amount. So these three attributes having list of 4 tuples. So according to the query, based on this select operator, we can define this select, that is sigma symbol, branch name equal periride of loan. That is, check the periride inside the relation loan, which is branch name is which comes under the branch name. So it selects the data periride based on the attribute branch name from the relation loan. So now when coming to this condition, it just retrieve the data which is in the table, that is which is in the relation of loan having in the third position. It just displays the content whatever is presented related to the periride branch name. So this is the concept of select operator, which selects the data from the relation. So next comes to the select, it is project operation. Here this operation shows the list of those attributes that we wish to appear in the result. Rest of the attributes are eliminated from the table. It is denoted by pi symbol, that is notation pi of a1, a2, an of r. Here a1 defines the attributes, a1, a2, an and all are attributes. That is, it is also similar to select operation. Instead of selecting entire attributes, we can just select the particular attribute which we desire to present the output. So here let's have another example for this project operation with the table name of customer, that is the name, street, city, having 3 tuples. In that the query is like this, that is pi name comma city of customer. Just select the name and city attribute of the table, that is relation customer. It displays the name and city itself. Just it will hide the street, or it will neglect the street attribute from the resulting relation. So this is the concept of project operator. So next comes union operation. This union operation helps in merging two tables. That is, the union operation contains all the tuples that are either in or S, or both in R and S. Just it entirely combines two tables. Whatever the content is there in table 1 and table 2, that is relation 1 and relation 2, it just merges and displays the new output. It eliminates the duplicate tuple. If there is same name content, it will just eliminate that particular content. So the notation is or that is table 1 union table 2. That here we have defined that R as one table and S as one table. So now R union S. A union operation must hold the following condition: R and S must have the attribute of the same number. This is another thing, that is when merging the tables, it defines that two tables should be in a same number. So here there are two tables with two tuples, that is borrow table and relation table. Here first we are defining using the project operator project customer name, that is selecting the attribute, which attribute to be displayed from the table name, that is borrow. That is first query. Next comes union, which operator, that is union operator, is used to merge the table here. That is why we are using union here. Now next comes project customer underscore name, that is the another table's names attributes of depositor. So again we are using by customer name, that is name of an attribute from the table name depositor. Here now the result will be customer name common from the both the tables, and it just measures the left and right tables. When combining, it starts with Johnson, Smith and Jones. When this two happens, there are two similar names are there, which is Smith in a customer name from the borrow table as well as Smith in the relation depositor table. So here it just adds only one name at a time because it will not support the duplicate entry. So this is the concept of union. Now let's see the concept of intersection. So intersection operation contains all tuples that are in both R and S. It is denoted by intersection. Suppose there are two tuples R and S, that is depositor relation as the same table we are considering here for an example, and as well as borrow relation. When this both tables are intersected each other, that is intersection is done using the intersection operator, the similar way of doing union operation. It just takes the similar content of both the table. So here it is having Smith in a left table as well as Smith in a right table, borrow and depositor table. It just takes the common names, common data from the both of the tables. That is why it is that is the concept of intersection. So as we have studied those things and all in mathematics, that is union, intersection and all, so the similar concept is applying here to retrieve the data from the relations. So this is the one. So next comes difference, that is set difference. So what is the concept of set differences? Let's directly go to the example here. So again just compare this both two tables, that is borrow and relation. Borrow is right side and depositor is left side. So from borrow we are making minus to the depositor. So when doing so, what happens is the left side table will be there, the right side table will be entirely, it will be deleted. So in this case what happens is when you are coming to the right side table, that is borrow is your right side table, that is left side table, first table, you can take the Jones from that particular customer name as Jones because Smith is there already in depositor also. So we are neglecting the table from the comparison. So we are doing the difference operator here, that is minus. From borrow you have to minus depositor. You are just neglecting entire thing, that is depositor table is getting deleted here and just borrow table is going to be displayed. But in this case there is a Smith name in depositor. When deleting this, whichever is related similar name is there in borrow relation also, it will just remove that one also. So this is the concept. If consider that in the depositor table instead of Smith there is some other name, then the output will be Jones and Smith because the left table, that is borrow table, is having Jones, Smith. When only comparing to this two table, while doing this difference operation, the similar content will be deleted and left side content only will be applicable to the resulting output. So this is the concept. So just go through on that once again so that you may be clear on this topic. What is set difference? It is just doing minus operation. Whatever the right side table is having, it is getting minused. Along with that, the similar content from the right side table to left side table is also getting neglected. So that is why it is just printing the Jones content. So next come Cartesian product. The concept of Cartesian product is just multiplying the first table's tuple with second table's rest of the tuples. So it is equivalent to matrix multiplication concept we can consider here. It is denoted by the X symbol. So see the example here. There is two tables with the employee details and the second table is with department table. So first table comes with employee ID, employee name and employee department. Following to that there are two tuples and next comes department table. Following to this there are two tuples. So when doing this employee Cartesian product, that is cross department, it just first takes the first row from the first table, that is employee table, and multiplies with both the rows of the second table. So see here, employee ID having 2 times printed in the resulting table and the department number is A, B, following to the department name marketing sales. Similarly again it will just start with multiplication with second row from the first table and again it will multiply with the 2 rows of the second table. So this is the concept for Cartesian product. So at last there is a rename operation which helps in renaming the table from one name to another name. Consider here the existing table name is student. We are using the symbol row of student 1 comma student. So left side student 1 is a new table name. You have to mention what the new name is going to be applied to the table and you have to enter the old table name for which table you are going to change the name of a particular table. So this is the entire concept of relational algebra with various operators of that. So I hope you may have getting some idea on this. Thank you.